Here's problem number 8. During a close flyby, the Cassini spacecraft yielded a new estimate of the mass of Enceladus. Enceladus is one of the very interesting moons of Saturn. At any rate, the mass of it turns out to be 1.08 times 10 to the 23rd grams. So notice that that's in grams. Given that the diameter of Enceladus is 499 kilometers, calculate the density. Um, calculate the density. What is the density? What does this density suggest about Enceladus's composition? So remember, ice has a density of about 1, and rock about 3 grams per cubic centimeter. All right. So and this is the answer. It turns out to be it turns out to be rounded to one place past the decimal, 1.7 grams per cubic centimeter. All right. So let's see how to get that. Right. So we know this the density equation, right? So here it is. Of course, density is mass divided by volume. So the mass is already in the proper units, right? So we're good to go as far as that goes. So you're going to put 1.08 times 10, 10 to the 23rd, all right, grams. All right, so that's what comes in the numerator. Now in the denominator, however, we have to figure out the volume. And the volume of anything that's spherical, and Enceladus is large enough to be spherical, is 4 times pi divided by 3 times the radius raised to the third power. All right, and R has to be, for us to do this properly, R has to be in centimeters. All right, so we're not even given the radius, we're given the diameter, but that's easy to figure out the radius. The radius, of course, is just half the diameter, so it's 499 kilometers divided by 2. All right, so that's going to be our diameter. I'm sorry, that's the radius from the diameter. And then, of course, we have to convert kilometers to centimeters. So we know that in 1 kilometer, there are 1,000 meters, and then there's 100 centimeters. So 10 to the third, which is 1,000, times 10 to the second, which is 100, is 10 to the fifth. All right, so there's 10 to the fifth centimeters in 1 kilometer. All right, so the kilometers will cancel. All right, so let's see what this turns out to be. Let me get my handy calculator. All right, so 490. First of all, 499 divided by 2. All right, so this is the radius, and then we say times 1 times 10 to the fifth. All right, so you could. There's several ways to write this. You could just write, for example, actually, before I even do this, you could just write 249.5. So this would be 249.5 times 10 to the fifth, right? Or I like to write that E5, and that would be centimeters. All right, so now to figure out the volume, right? The volume is going to be equal 4 pi divided by 3. That just comes from geometry. And now I got to take this number 249.5 times 10 to the fifth. Of course, it's centimeters, and then now I've got to cube that. It's supposed to be a 3. All right, so I'll take care of all that in the calculator. All right, so here we go. All right, so that this is the part where I was multiplying it times 1 times 10 to the fifth. All right, so this is what it equals. It's not going to be in scientific notation with this calculator, but that would be, let's see, what would it be? It would be 2.495 times 10 to the seventh. All right, and it's the same number whether you write it in scientific notation or regular. And then of course we multiply by 4, multiply by pi, and then divide by 3. All right, so this is the volume. All right, so the volume here. Let me. I'll write it in scientific notation. All right, so notice. So it would be 1.045, something like that. So 1.045, 1.045 times 10 to the what? Let's take a quick look here again. All right, so let's see. Let me make sure I did this right. All right, so I just paused it because I didn't do it right initially. All right, so anyhow, there's the 249.5, and then times 10 to the 5th. All right, so the thing that I forgot to do is cube this. All right, so I got to cube that raised to the 3rd power, and then we multiply by 4, and then we multiply by pi, and then we divide by 3. All right, so that's the number right there. All right, it's this huge number. It's going to be so let's see. It's going to be. All right, let me count this here. I'm going to pause it and turn it into scientific notation. So the volume turns out to be. See, I messed this up. Let me erase it. All right, so the volume turns out to be 6.5. 6.5 times 10. All right, so here, let me take a quick look at this again, just to make sure I got it right. I think it's times 10 to the 22nd. All right, so the decimal is right here between the 1 and the 3. All right, so there's 6, there's 12, there is 15, 18, 21, 22. Okay, so 6.5 times 10 to the 22nd. 10 to the 22nd. And of course, now it's in cubic centimeters. So I take that number and I put that right here. So I divide by, I'm actually going to divide by the unrounded number that's in my calculator, but this is basically what I'm doing. 6.5 times 10 to the 23rd, centimeters cubed. Right, and so let's see what the answer turns out to be, and we already know it should turn out to be 1.7. All right, so here, let me get my calculator. All right, so that's remember, this is going to be my denominator. So here, let me store that real quickly. So put that into memory storage. All right, so 1.08. Remember this is the numerator which was given to us. That was what the spacecraft measured very accurately. All right, it's times 10 to the 23rd. All right, and that's already in grams, divided by my volume, which I just put into memory. All right, and so that turns out to be, all right, so 1.66, and they want us to round it to one place past the decimal. So that would be 1.7. All right, so 1.7, because of course the 6 is greater than 5, so I round up. So it turns out to be 1.7 grams per centimeter cubed. All right, and so notice that's between ice and rock, right? So remember, this is the average density of this tiny moon Enceladus, and what that tells us is actually it's not composed purely of rock. If this is the average density, there's going to be stuff that's much less than the 1.7, and then there's going to be some stuff that's more dense than 1.7, and averaging out to that number of 1.7. All right, so that is number 8.